इसी पे एंड करना है। Good morning students. Today we discuss about grinding operation. In this lecture, first we will discuss about the definition of grinding operation, its working principle, various shapes of the grinding wheels and the various types of grinding operations. Next we will discuss about the basic formula to calculate the machining time, and we will also solve a numerical problem on grinding operation for the calculation of machining time. So first, what is definition of grinding operation? So it is basically defined as the operation of removing material from the workpiece in the form of small chips by means of rotating abrasive particles bonded together in the form of a grinding wheel. Next we will take about the principle of grinding. So here are two main elements. Here is your workpiece and this one is grinding wheel. So workpiece is fitted on the table below the grinding wheel, and the grinding wheel is rotating about its own axis, maybe horizontal or maybe vertical, and is removing material from the workpiece in the form of small chips. And the material is removed due to the rubbing action or friction between the material of the workpiece and the grinding wheel. So next slide shows the basic shapes of the grinding wheels which we commonly use in the workshops and in the different industries. Next we will discuss about the types of grinding operations. So depending upon the position of the axis of the grinding wheel, we have basically two types of grinding operation. One in which spindle axis is in the horizontal plane and the other one is the vertical. So in case of a horizontal spindle type grinding operation, the axis of the grinding wheel is in the horizontal plane. So this is the axis. About this the grinding wheel is rotating in the clockwise or anti-clockwise direction, and this one is the workpiece which is fitted on the reciprocating type of table. The second case, the table shape is of rotary type. The table movement is like this. And we also use some coolant to take away the heat produced during grinding. The second category, in which the axis of the grinding wheel is in the vertical plane, that the grinding wheel will rotate clockwise or anti-clockwise about this vertical axis, and the table here is used of rotary type. And the second case in which the table use is of reciprocating type. So these are the two types of grinding operations depending upon the axis of spindle. Now next, types of grinding operations. So basically first we have surface grinding. This is the basic diagram in which the work is fitted on the table and is given speed left to right, and the grinding wheel is rotating about this horizontal axis. Second category of surface grinding, in which the axis of the grinding wheel is in the vertical plane. third type of grinding operation is cylindrical grinding. It is somewhat similar to turning operation on a lathe. In this, the workpiece, here is the workpiece fitted between the centers and the grinding wheel. You can see the rotating grinding wheel is forced against the workpiece to make it more accurate size and surface finish. Fourth category, internal cylindrical grinding. Here is the workpiece, this one is the workpiece, and this one is the grinding wheel. Next category is centerless grinding, very important. In this there are two wheels, first one is the grinding wheel and second one is the regulating wheel. And here is the workpiece supported on a rest. Next category, form cylindrical grinding. So depending upon the shape to be produced on the workpiece, the grinding wheel is made of that shape, and that replica of the grinding wheel shape is produced on the workpiece. So here is the job. So I hope you have understand the basic grinding operations. So next we will take about the types of grinding operation for calculation purpose. First one is surface grinding. So here is the rotary table, this one is the spindle, and this one is the grinding wheel, and this pink one is the workpiece. The diagram is self-explanatory. So this type of surface grinding is used to produce flat surfaces, and this is somewhat too similar like milling operation. So we will use the milling formula for calculation the machining time for grinding. So we have taken two cases in milling. So first, when using the width of the grinding wheel, time can be calculated by the same formula used for cutting operation in milling, and when using the face of the grinding wheel, time can be calculated by the same formula used for facing operation. The next slide about cylindrical grinding. In cylindrical grinding, I've already said that this is somewhat similar to turning operation. So here is the workpiece and this one is the grinding wheel. So rotating grinding wheel is pressed against the cylindrical workpiece. The cylindrical workpiece may be to grind external or internal surface. Here is the main objective is to make it more accurate size and smooth finish, and time required can be calculated by the same formula used in turning operation. So here is the formula for grinding time per cut, that is equal to length of cut by speed per revolution multiplied by RPM. So this is grinding time per cut is L by F into N. Now what is L? L is the length of cut and is equal to length of the job plus over travel, and we generally take over travel as 0.5 centimeter. Next is speed per revolution, F. F in case of grinding, if we are using the rough cut, then speed per revolution is equal to W by 2. And if we are taking finishing cut, then F is taken as W by 4. Now what is W? W is the width of the grinding wheel. Mind the width of the grinding wheel. Now I will take one numerical to understand this operation. I am reading the statement. Calculate the time required for rough grinding in a 20 centimeter long shaft. So the length of the job is 20 centimeter. To reduce its diameter from 4 centimeter to 3.8 centimeter. So diameter of the job given is 4 centimeter, and we have to reduce it to 3.8 centimeter. With the help of a grinding wheel of 2 centimeter case width, W, that is case width given is 2 centimeter. Take cutting speed as 20 meters per minute and depth of cut as 0.25 mm. So we have to calculate this grinding time, that how much time it will take to finish the job in case of rough grinding. So first we calculate the length of cut. Length of cut we know equal to length of the job plus over travel. So length of the job is given, that is 20 centimeter, and over travel we know that is 0.5 centimeter. So length of cut we have calculated as 20.5 centimeter. The next parameter, that is speed per revolution, because it is a rough cut. So F is equal to W by 2. So W we have given, that is 2 by 2. So we have calculated speed per revolution F as 1 centimeter. So next we will calculate N, RPM. We know the standard formula of cutting speed in case of turning as S is equal to pi dN by 100. This is the basic formula. So we will calculate N from this formula as 100 as on pi d. We put the values. S is 20 d4. So we have calculated N as 159 RPM. Now we will use the standard formula for calculating the grinding time per cut. P is equal to L by F and Y. So we put the values and we are able to calculate the grinding time per cut is equal to 0.13 minutes. Now this is the grinding time required, that is 0.13 minutes for one cut. So next we have to calculate how many cuts are required. So it is calculated by the formula amount of stock to remove divided by depth of cut. So amount of stock is 0.1 centimeter, तो मिलीमीटर में बना लिया हमने 10 से मल्टीप्लाई करके डेप्थ ऑफ कट इज 0.25. So we have calculated as 4 number of depth, 4 number of cuts are required. So total grinding time for 4 cuts is equal to grinding time for 1 cut multiplied by number of cuts. So we have calculated as 0.52 minutes is the total grinding time. I hope you have understand this basic formula. I hope you have liked the lecture. If you like the lecture, please share with your friends. Thank you.